Alright, here we go with 3.6 video, compound inequality. So up till now we've only dealt with one inequality at a time, which is called a simple inequality. This is called a compound inequality, which has two of them in it. So after this lesson I'll be able to solve and graph compound inequalities containing the word and also solve and graph compound inequalities containing the word or. So there's really two kinds of compound inequalities. Ones that involve the word and ones that involve the word or. Let's take a look at a situation. Claire takes her brother to the carnival. When they arrive at the bumper cars, there is a sign that reads that all riders must be at least 48 inches to ride. The sign also reads that the riders cannot be more than 72 inches. If Claire's little brother is allowed to ride the bumper cars, what are some possible heights he could be? Well, if he's going to ride, he has to be more than 48, or at least 48, excuse me. So he could be 48. He could be 48, he could be 49, he could be 50. He could be any of the fractions in between those numbers, like 48 and a half. And he can go all the way up to 72, but he cannot be more than 72. So 48, 49, 50, 51, 52, 53, 54, all the way up to 70, 71, 72. Again, he could be the decimals in between these also. He just can't be smaller than 48, and he can't be more than 72. So the range of those heights, well, he can be any height, 48 or more, but he also has to be less than or equal to 72. So there's a range in where he's allowed to fit. Maybe a little easier to say would be any height between 48 and 72, including the 48 and 72. Because he would be allowed to ride if he was 48, and he would be allowed if he was 72, and he's allowed to ride if he's anything in between those two. Okay, so symbol-wise, his height would be greater than or equal to 48, but his height also has to be less than or equal to 72. So if I was going to combine those two, his height has to be greater than or equal to 48 and also at the same time smaller than or equal to 72. So his height is greater than or equal to 48 and less than or equal to 72. So that fits in that range of 48 to 72. So if I was going to make a graph of that, well, there's 48, there's 72. I'd have a closed circle on the 48. I'd have a closed circle on the 72. If I was going to shade everything greater than 48, that would go all the way over here. And everything smaller than 72, well, that would be everything over here. So the numbers that work for both, because it has to work for both things in order for them to be allowed to ride, would be these numbers in the middle. Right there. So my picture would look like that. All of the numbers in the middle are solutions. They work for both of the inequalities. Okay? A compound inequality consists of two distinct inequalities connected by the word and or the word or. So there's two different kinds. As long as you can keep those two straight, you'll be all right. A graph of a compound inequality with the word and contains the overlap of the two graphs of the two inequalities that form the compound inequality. Here are some examples of the inequalities with the word and. So if the picture were to look like this, with the two boundary points, so I put a boundary point at -2, I put a boundary point at 3, and I shaded in the middle. All right, that's what an and graph always looks like. This has a closed circle. This also has a closed circle. So that tells me when I write those boundary points, I'm going to have those equal signs on the bottom of my inequality. So what do I see here? Well, this part of the picture, everything to the right of -2, tells me all the numbers greater than or equal to -2, or equal because it's shaded in. To the left of this boundary point is all the numbers less than or equal to 3. So both things are true because it's knocking between these two. Okay? So the numbers that are shaded in red here are all the numbers between -2 and 3, including -2 and including 3, because those are filled in. All right? So it's very easy to write an and compound inequality as one statement. Numbers between -2 and 3. Okay, notice the symbols. X is greater than -2, or -2 is less than X less than 3. All right. So as long as you write your inequality from smallest to biggest, smallest number, biggest number here, your symbols will always face the same way. Okay? So anytime you write an and inequality, your symbols will always face the same way. They'll always go like that. And now it's just a decision, am I going to fill the dots in or not? So since they are filled in, I got equal signs there, bang. All right, here's another and graph. So let's put a boundary point at 0. Notice it's not filled in. And let's put a boundary point at 4, which is filled in. Okay? So we're talking about all the stuff in between. All right? Those are the solutions that work for both. That's what an and graph is. It's working for both. So what do I see here? I see all the numbers bigger than 0 and also less than or equal to 4. Or equal because it's filled in. All right, notice no equal sign because it's not filled in. All right. So again, with a compound inequality, we like to write it as one statement. All the numbers bigger than 0 and also less than or equal to 4. If you put the smaller number on the left and the bigger number on the right, your symbols will always face that way. Okay, here's what an OR graph looks like. So let's put a boundary point at -2. Let's put a boundary point at 4. I'm shading to the left of -2. I'm shading to the right of 4. All OR graphs look like this. Point, point, shade on the outside, shade on that outside. Okay? So an OR graph is not in the middle. It's either this side or it's on that side. So numbers over here work or numbers over here work. So numbers can't be less than -2 and also bigger than 4. No number is less than -2 and also bigger than 4. That's why it's an OR picture. So what do I see here? I see numbers that are less than -2 or they are greater than or equal to 4. All right, kind of like if you go to a restaurant and kids eat free and senior citizens eat free. Well, let's say your kids are less than 10. So people less than 10 eat free, and then your senior citizens over 65 eat free. So people greater than 65 eat free. So in order to eat free, you either have to be less than 10 or more than 65. Okay? So that's an OR kind of graph. Here's another OR picture. So notice all OR graphs always look the same way. Point, point, shade the outsides. So these are filled in. So these are going to have equal signs in my inequalities. All right, both of them. But what do you see here? You see all the numbers that are less than or equal to -4. You see all the numbers that are greater than or equal to 3 here. So you just write it in inequality. Less than or equal to -4 or greater than or equal to 3. Okay, when we do an OR, we never put it into one thing like we did with an AND. We always just leave it as 2 with the word OR in the middle. So that's easy to tell that it's an OR because it has the word OR in the middle. Alright, so now I got to write some inequalities. Alright, of real numbers that are greater than -2 and less than 6. Well, greater than -2, that's easy, and less than 6. So I need numbers greater than -2 and also less than -6. With and graphs or and inequalities, we like to write them as one piece. So x is between -2 and 6. Literally, look at it. X is in between -2 and 6. It's more than -2. It's less than 6. Picture would be real simple. There'd be a dot at -2. There'd be a dot at 6. Open circle, because there's no equal signs. Shade the middle. All and graphs are the middle shaded in. Okay, here's an OR graph. So all real numbers that are less than 0 or greater than or equal to 5. All right, greater than or equal to 5. Okay, so I see all numbers that are less than 0. Okay, that part's pretty easy. Or x is greater than or equal to 5. All right, so the OR here, and then this is the greater than or equal to part. So x is greater than or equal to 5. It's an OR, so I have to leave it as 2 different pieces with the word OR in the middle. I just leave it. Picture would look like this. I got a 0 as a 1 point. I got a 5 as another point. You could have all the other numbers in here. 1, 2, 3, 4, 6, 7, 8, 9, -1, -2, -3. You could have as many as you want, but basically this is what the picture looks like. So less than 0, open circle on the 0, close circle on the 5, shade the outside, shade the outside. All OR graphs have the 2 points and then the outsides shaded. Okay, what do we see here? All real numbers that are greater than or equal to -4 and less than 3. So it's an AND graph. Well, greater than or equal to -4 and x is less than 3. All right, so those are the numbers that work. Ands we like to write as one thing. So what do we got? Numbers bigger than or equal to -4 and less than 3. So I try to write it as one inequality. All right, again, as long as you put the smaller number on the left, the bigger number on the right, the symbols will always face that way. So on your picture, there's your dot at -4, there's your dot at 3, closed circle at -4, open circle at 3. It's an AND graph, so you'll shade the middle. Those are the points that work. All right, OR graph. All real numbers that are less than or equal to 2 or greater than 4. Less than or equal to 2 or greater than 4. Well, less than or equal to 2 or greater than 4. Pretty simple. Picture would look like that. There's a spot at 2. There's a spot at 4. Again, you could have all the other numbers in here. 1, 0, -1, 3, 5, 6, 7. Okay? Alright, just try to keep it simple as possible. Closed circle on the 2. Open circle on the 4. It's an OR, so I always shade the outsides. Donezo. When you solve a compound inequality, break the problem into its 2 inequalities and solve each part. So really, I go back to my rules for solving an equation or an inequality. Alright? So here's, they gave me an inequality. Compound. Notice there's 2 symbols in it. There's a less than or equal here. There's a less than here. Okay, so this is 2 inequalities. So when I break this apart, this middle piece goes with both expressions. The whole middle, everything between the 2 signs, this whole m-4 goes with both pieces. So they're telling me it's one long expression. It has 2 inequality signs. That makes it an AND problem. So I know that the graph is going to be the 2 points with the middle shaded in when I go to graph it. So here's one of the inequalities. Start from the left, go all the way until you hit the second sign. All right, so there's one of your inequalities. -3 is less than or equal to m-4. There's one of them. Here's the second one. So again, the whole middle, everything between those signs goes with the whole problem. I would suggest that you draw these boxes each time. It'll make your life easier. So m-4 is less than -1. Looks like that. So now it's really just 2 problems. You know, we've been doing these problems for a while. So you just have to solve them. So go down your list. There's nothing to distribute. There's no like terms on each side. Use addition and subtraction to move your letters. Well, all the letters are on the right here. Use addition and subtraction to move the regular numbers. So I got to move this -4. So I would add 4 to both sides. And that tells me that m is greater than or equal to 1. Or 1 is less than or equal to m. Okay, so there's one of them. Now we just solve the other one. Same idea, add 4, and m is less than 3. Okay? So if I were to write that as one thing, m is greater than or equal to 1, m is less than 3. So all the numbers between 1 and 3, including 1. Picture, well, there's going to be a spot at 1, there's a spot at 3. You could put a 2 in the middle here if you wanted. You could put a 4 and a 5 and a 0 and a -1. But in any event, it's going to have a closed circle on the 1. It's going to have an open circle on the 3. And you're going to shade the middle like that. It's an AND problem, so the middle gets shaded. All right. Here's another AND problem. All right, pretty simple. This is number 3, so make sure you're on number 3 on your paper. What are the solutions? It's another AND problem. That's why I went to this one. So it's one long expression. So it's an AND problem. Again, the graph will be the 2 points with the middle shaded in. So when I break it apart, the whole middle, everything between the 2 signs, everything goes with both of the problems. So here's one of them. -2 is less than 2y minus 4. And then here's the second one. The whole middle, notice that whole 2y minus 4 is in both problems. 2y minus 4 is less than 14. So now I just have 2 problems, and I just solve them. So no big deal. Use your checklist, go through, add 4 to both sides, divide by 2, and y is greater than 1. All right, pretty simple. Second problem, add 4 to both sides, 2y is less than 18, divide by 2, and y is less than 9. So in neither one of these problems did I have to remember about flipping the sign around or anything like that, right? Because I divided by positive, so it was all good. No big deal. This is an and problem, so I'd like to give it back to them as a one statement kind of thing. So y is bigger than 1, that's this part. Y is smaller than 9, y is less than 9, that's this part. So all the numbers between 1 and 9. Picture's real simple. There's a 1, there's a 9, open circles on both. It's an and problem, shade the middle. Those are all the numbers that work. All right, here's number 2. All right, so go back to number 2. Now what you see here, it's still solving, so it's still just your checklist and everything. Now it's an or problem. Well, how do you know it's an or problem? It literally has the word or in the middle, so that makes it an or problem. So I know the graph's going to be the 2 boundary points, and then the outsides are going to be shaded. The good thing about ORs is they're already broken apart. I don't have to worry about breaking them apart. So I just solve the problem. There's one of them. There's the second one. All right, so when I solve the first one, subtract 2 from both sides, divide by 3, and t is less than -3. Pretty easy. Second one. Okay, now watch this. Be careful. Subtract 5 from both sides. -4t is less than -4. Divide by -4, and as soon as you say divide by negative and you write down divide negative, the little alert should go off in your head to remind you to flip the sign around. So now t is greater than 1. It's an or problem, so you can't put it back together into one piece. It has to stay in 2 pieces. T is less than -3, or t is greater than 1. So remember what your picture should look like. There's -3, there's 1. Open circles on both. It's an or, so you shade the outsides on both. This is all the numbers that are less than -3. This is all the numbers that are bigger than 1. Okay? So remember your rules. Here's number 4. It's already broken apart. It's an or problem. It has the word or in it. It doesn't get easier than that. I know that the picture will be the 2 points with the outside shaded. There's the first one. There's the second one. Alright, I just follow my checklist. Subtract 7 on both sides. -2y is less than or equal to -6. Be careful. You're dividing by -2. So there's your alert. Y is greater than or equal to 3. I flipped it. Now notice, -6 divided by -2 is +3. Okay? Over here, on the right, subtract 3 from both sides. 4y is less than -8. Divide by 4. No flip, because you're dividing by a +4. All right? Even though you're dividing a negative number, you're dividing by a +4. Notice your alert. When you multiply or divide by a negative, here you're dividing by a +4. So y is less than -2. So all the numbers that are less than -2 or greater than or equal to 3. So here's your points, -2, 3. All right, open circle on the -2. Notice, even though this one was on the left, when you go to graph it, he's got to be on the right because he's actually bigger than -2. So on your picture, you have to put them in the right order from smallest to biggest. Less than -2, open circle. Greater than or equal to 3, closed circle. It's an or problem, so you're going to shade the outsides. All right? Hopefully you got that. I'll see you next time. Peace.